Hello and welcome everyone to tonight's Royal Meteorological Society meeting. My name is Komalika Sengupta. I'm the chairperson of the Yorkshire Centre. And it's my privilege tonight to chair this event. Before I introduce the speaker of tonight, I'll just go through the logistics first, especially for those of you who might be joining us for the first time tonight. So this talk is going to be recorded and it will be uploaded on YouTube in a week's or so time. The talk will last about 30 minutes, after which we will have a short Q&A round. Type any questions that you have at any point on the chat box. So if you see on the top right-hand side of your screen, you will see a chat icon and that will open the chat box for you. And feel free to send your questions at any point during the talk. I'll share the talk tonight, as I said, but in case I were to lose connection, my co-chair and fellow committee member Tom will take over, so don't worry. Now, coming to the talk tonight, the title of the talk is Clean Air is Essential for a Sustainable World, and this will be presented by Dr. Sagnik from Indian Institute of Technology, Delhi, which is in India. Dr. Dey is an institute chair professor at the Center of Atmospheric Science in IIT Delhi in India, and he is joining us from India at the moment. Prior to joining IIT Delhi, he received his master's in applied geosciences from Jadavpur University in Kolkata, and then he did his PhD from IIT Kanpur in India as well. Following that, he worked as a postdoctoral scientist at University of Illinois in the US. Dr. Dey has worked extensively on air quality, climate change, and health impacts. He is the coordinator of the Center for Excellence for Research on Clean Air and is an associate faculty of School of Public Policy at IIT Delhi. He's also a member of the Southeast Asia Non-Communicable Diseases Regional Technical Advisory Group, and he served as an expert member of the World Health Organization Global Platform on Air Quality and Health, and is a science team member of NASA's upcoming MAIA satellite mission. On a personal note, I have worked with Dr. Dey for a couple of years before joining my PhD program in the Leeds, so it's my privilege to welcome him for the talk tonight. With that, I'll pass on the meeting to Dr. Dey for the talk titled Clean Air is Essential for a Sustainable World.
Yeah, thanks, Kamalika, for the kind introduction. Am I audible?
Yeah. Yes, you are.
Okay. Thanks again.
It seems
it's a pleasure to be here and talking about our recent work. So today I will talk about why clean air is essential for a sustainable world. And I want to acknowledge the contributions of my research group and various collaborators from India and abroad. So I'm going to talk about three critical issues in today's presentations. First, I will give evidence why air pollution mitigation is so important, not just for one or two sustainable development goals set by the United Nations, but many of them. And then I will talk about the challenges faced by the developed and developing world in air quality management. And then finally, I will talk about what is the way forward and what the world has to do.
We have some issues with Dr. Dey's connection. Please bear with us. Yep, we can hear you now.
Hello. I do not know. I mean, okay. Okay. So, sorry actually for that. So what I was saying is that, for quite a long time in the developing world, there is a great disconnect between the environmental science aspect of the air pollution problem. That means you measure air pollution and then try to understand what is happening, with the social science aspects where we actually talk about the exposure, because what we are measuring may not be the exposure level to which the population is exposed to. Just imagine, like, you have a monitor out there which is measuring air pollution, but let's say PM particulate matter smaller than 2.5 micron, we call it PM 2.5. And we are inside our home, or at least 5 kilometer, 10 kilometer away from that monitor. So clearly we are not breathing the air what the monitor is actually showing us. So because of this disconnect, there is a lot of difficulty in understanding the health impact, because when it comes to the health impacts, again, it comes under the domain of medical science. So you can see that unless we really integrate environmental or atmospheric science, social science, and medical science in a seamless pathway, we cannot really develop an efficient air quality management plan. And that requires clearly an interdisciplinary approach. In more recent years, we have understood, in fact, the developed world understood this decades ago. So obviously there is an opportunity to leapfrog and learn from the experience there. And today I will show you actually that what is the basic difference in terms of the air pollution problem in the developed and developing countries. For example, this figure taken from the work by Randall Martin's group shows the global distribution of one important criteria air polluted, PM 2.5. The top panel here shows a long-term average exposure level of PM 2.5, and the bottom panel shows the trend over the last almost 2 decades. And what you notice here is that there is quite a disparity across the country. For example, if you look at US, pollution level is around 10 microgram per cubic meter. Then you come to Europe. Again, within Europe, there is quite a variability. There are places where the pollution level is quite low, but also at the same time, in the Eastern Europe, PM 2.5 level is around 20 to 30 microgram per cubic meter, shown by the yellow color. But if you come to Africa or Southeast Asia, you see these patches of red, where actually you can see from the scale that pollution level is more than 50 or 60 microgram per cubic meter volume of air. And this is very, very high level of exposure, because in a minute, I will show what is the WHO air quality guideline. So you can see that, across the world, the air pollution level varies by a very large margin. But also interestingly, if you look at the bottom panel here, it shows the trend over the last 2 decades. And again, you can see that over US or Europe, the trend is mostly negative. That means this part of the world successfully reduced the air pollution level over the last 2 decades. Unfortunately, the Southeast Asia, particularly India, from where I belong to, everywhere in the country, you can see that the air pollution level has increased by a very large margin in the last 2 decades. China has seen mixed success. For quite a long time, the air pollution problem, it was a very big problem in China, but you can see that more recent years, there is an overall improvement in the air quality. So different countries handle air pollution in different ways based on their local sources as well as the regional transport. But before that, let us dive into the connection between the air pollution and the different sustainable development goals. Okay, so if you talk about the first and eighth Sustainable Development Goal. The first Sustainable Development Goal set by the United Nations is basically eradicating poverty. And the eighth Sustainable Development Goal is actually to promote economic growth. And particularly if you see this figure here, it shows that what fraction of the population, global population, lives below poverty line. So obviously we can see that there is a quite improvement. For example, in 2010, almost 16% of the global population lived under poverty line, which decreased over the years. However, what is projected in this particular figure shows that if the current rate continues, then still in 2030, which is the target for the Sustainable Development Goals, still 6% of the global population would remain below the poverty line. And it means that we will miss this particular important target. More recently, because of the COVID pandemic, just in 2020, more than 70 million people actually are pushed to extreme poverty. So on top of that, in the right panel, if you see that there are estimates about the economic loss due to air pollution for different countries. And you can see that actually these numbers are quite big. For example, in China, air pollution contributed to almost 6.6% loss in GDP. In India, the number is 5.4%, and so on and so forth. So obviously, the question comes that, why there is an impact on the economy from air pollution. Obvious reason is that there is a big healthcare expenditure associated with air pollution. So if people are exposed to high level air pollution, they develop certain diseases, which has a healthcare cost. And also if ultimately people die out of air pollution, you are actually losing very valuable workforce, so which can be again monitored. So clearly, in a polluted air, there are a lot of risks associated, which ultimately contributed to big economic loss. Then if you think about why clean air is required for the Sustainable Development Goal number 2, which is actually providing adequate food supply. And again, if you see that large percentage of population is already under tremendous food scarcity, for example, and because of that, almost 21% of children under 5 are stunted. So stunting is a measure of child growth failure. And similarly, wasting is another measure of child growth failure. So basically, stunting means the child growth during the first 5 years of the child's life is not as expected according to the standard height chart. And similarly, the wasting means the child is underweight actually as per the age. And again, why it's so important to talk about, for example, stunting and wasting, because any stunting and wasting in the first 5 years of life means that the child has very high chance of developing non-communicable diseases as an adult, which ultimately will hamper the child's actually overall health. So already there are many other factors affecting the food security. For example, climate is one important factor. But on top of that, what we have found from research is that poor air quality impacts crop productivity, particularly high level of ozone and high level of particulate matter severely reduces the crop productivity. And also indirectly, air pollution impacts climate. And again, there is a connection. But at the same time, also what has been observed is that poor air quality activates malnutrition. Particularly, it increases the stunting and wasting. And we have done a study in India recently with colleagues in US. And what we have found is that on top of malnutrition and also of poor sanitation, air pollution is the third largest risk factor for child stunting and wasting. So again, it clearly demonstrates the importance of achieving cleaner air. The third Sustainable Development Goal, obviously, this is a no-brainer. This talks about promoting a healthy life. So what you are seeing here, these two tables, these are actually the ranking of the various risk factors identified in the global burden of disease. This is an initiative which is, you can say, kind of equivalent to what IPCC is doing for climate. Large part of Europe and United States actually has improving air quality over the last 2 decades. And the reason that you can see this, that the risk factors of the air pollution coming down in more recent years is due to that. However, if you talk about the developing world, particularly the Southeast Asian region, air pollution ranks still among the top 2 risk factors. So at the right side, you can see that I have listed the top 5 countries where, in terms of mortality attributable to air pollution, and you can see that China and India, almost more than actually 1 million people are estimated to die from air pollution every year. And in China, air pollution was number 1 risk factors, and in India, air pollution was number 2 risk factors after malnutrition. And then actually the list is US, Indonesia, and Brazil. This completed the top 5 countries. Couple of important points here. If you look also at the exposure level across these 5 countries, and it's quite different. For example, in China, the exposure level is around 58 microgram per cubic meter. In India, 74. However, in US, you can see that the exposure level is 8.4. And what you notice here is that even if the exposure is 8 microgram per cubic meter, still you can see that 88,000 people die. And I will touch this in a minute, that how clean actually we need to be, in order to really reduce the burden. So let us move on to other sustainable development goals. For example, when you talk about Sustainable Development Goal 4, which talks about the quality education, so there are several studies which have shown that if the child is exposed to air pollution, it affects significantly the cognitive performance. And that means the child's performance, in academic curriculum will definitely get impacted. In terms of gender equality, which is the objective of the Sustainable Development Goal number 5, clearly women are more affected than their male counterparts by air pollution, particularly in the Southeast Asian region, for 2 reasons. One is that in Southeast Asia, we have very high household air pollution level or indoor air pollution level. And a large fraction of the population in this part of the world uses solid fuel for cooking and heating. And because mostly in this part of the world, women actually are associated with such kind of domestic activities, their exposure level is much, much larger than the exposure level of the male populations. And also, culturally, women are more likely to attend to the children and elderly when they become sick because of the air pollution. So because of these reasons, you can clearly see that there is already, it's affecting more, it's affecting women more. The Sustainable Development Goal number 10 talks about inequality. And again, we know that poor people are more vulnerable to air pollution. In fact, there is a very nice story covered by New York Times recently, where they picked up this 2 child from Delhi, where I live, one of the most polluted megacity in the world. So one child, Monu, the boy, he is from a poor background. poor family, and then the girl, Amaya, is from an affluent family. And although they both live in Delhi, what has been observed is that because Amia's parents can afford air purifiers and she always travels in air-conditioned car, her school is actually also air-conditioned. So overall, her exposure level is 10 times smaller, 10 times lower than the exposure level of the boy. So clearly, put actually the poor people at disadvantage if the overall exposure, if the overall air pollution level is high in a city or in a country. If you talk about the other sustainable development goals, there are studies which have clearly shown that if you have high level of air pollution, it impacts solar power production significantly. Now, why solar power production is so important? Because in order to not just reduce air pollution, but also to address climate change, we need to gradually transition to renewable energy, and solar energy is one of the key contender for that. And what has been observed is that high air pollution, first of all, it cuts down the radiation reaching the Earth's surface, and it means that even if you put up your solar panels, ultimately you will receive much less radiation than you expect. And also what happens is that if you have high level of air pollution, the particles get deposited on the panels, which ultimately reduce the efficiency of the solar power generation. If you talk about SDG 11, again, there is tremendous pressure on the urban centers, and particularly in the Southeast Asia, because of the migration for economic purposes, and that actually creates tremendous amount of air pollution, and again, very high burden, and ultimately it means that people are trying to move to these urban centers at cost of their own lives. And then finally, if you talk about SDG 13, as I mentioned, air pollution and climate change are interlinked. We all know that aerosols affect Earth's climate directly and indirectly. So obviously, there is a strong connection between air pollution and how they impact overall radiation budget, clouds, precipitation, and it means also that if you talk about reducing air pollution, we must understand how such actions will result in differential feedback. So, it's very clear, from these discussions that for so many different sustainable development goals, we definitely need clean air. So now question is that how clean is actually clean? So in the table here, you can see that various standards. For example, WHO defines air quality guideline at annual and 24-hour scale, particularly for PM 2.5. So annual guideline is 10 microgram per cubic meter, and 24-hour guideline is 25 microgram per cubic meter. So what is the implication? So the implication is that WHO is saying that if the exposure to PM 2.5 is less than 10 microgram per cubic meter, then there is minimal health impact. However, there are studies done, particularly this famous study, ESCAPE in Europe. It has shown that there are actually health impacts even at exposure level lower than 10 microgram per cubic meter. And if you recall what I mentioned when I showed the top 5 countries, in US, on an average, the pollution level is 8 microgram per cubic meter, which is slightly smaller than the WHO air quality guideline. And yet we have found that almost 88,000 people die every year out of air pollution. So the question comes actually, and then there are different countries who have set different air quality standards. For example, US, for primary pollutant, it's 12, and for secondary, it is 15. And at annual scale for European Union, it's 25, China 15, and India, it's actually set at quite high, 40 microgram per cubic meter. Now, if you look into, again, the global burden of disease framework, what we have been finding is, what have been observed is that GBG identifies the lowest level of exposure in the range of 2.8 to 5.2 microgram per cubic meter. It means that if your exposure is as low as 2.8, then you have actually no health risk. And any exposure above 2.8 microgram per cubic meter, you have some amount of risk. and that's actually raises the questions that when you are seeing that you're already around 10 or 12 microgram per cubic meter, which is very close to the WHO air quality guideline, although there is health risk. And this is actually the problem faced by the developed countries like US or UK or other European countries, that, and in fact in Australia also, that it's very difficult to further convince the government, that we further need to go down to 2.8 or, 3 microgram per cubic meter. Because then the argument of the government is that, we are already, quite successful compared to many other countries in the world. Our air pollution is much, much lower. So why we need to go all the way to 2.8? So that's where the research is now, focusing on, to understand both at the lowest end of the exposure spectrum versus, what happens when you are at the extreme end. So India is one such country where the exposure level is at the extreme end. And I will show some of the, policy and other important, research, what we are trying to do and convince the government for the other extreme end. The challenge in the developing countries are inadequate ground-based monitoring. So this figure here shows, so it's a complicated figure, so let me walk you through this figure. So right now, just focus on the color of the country boundaries. And this color here indicates that what is the mean distance of the population from a nearest ground-based monitoring network. So for example, if you look at Canada or US, the color is in blue. If you look at the scale, and it means that the nearest monitor is within 2 to 3 kilometers. However, if you go to country like India, nearest monitor is almost 80 to 100 kilometers away. If you go to Africa, it's even worse. So in Africa, on an average, the nearest monitor is more than 500 kilometers away. So it simply means that, we are not really having adequate ground-based monitoring to get a sense what is the pollution level and then take a decision on it. And that is why satellite data become a very important tool in the current context, particularly in the Southeast Asian region. And in India, and it means that and in this corridor where you can see this brown patch, 700 million plus population lives, and you can just imagine the kind of health impact that is expected. So we have done studies to understand, first, obviously the target is to meet the national standard. And obviously for air pollution management perspective, we need to understand the differential source contributions. And what we found is that, very interestingly, in India, the reason why the pollution level is so high across urban and rural regions is because a significant proportion of the population still uses solid fuel for cooking and heating purposes. So this map in left, it shows contribution of household emissions to the outdoor PM 2.5 in terms of percentage, and you can see almost 40 to 50% of the outdoor pollution level comes from this household activity. And when we calculated that if we mitigate the household activities, what will happen, and you can see the right panel here, All the districts which are shown in blue color, so those districts actually will meet the national standard if we completely eradicate the household air pollution. And the right panel shows actually how air pollution changed during the lockdown India implemented last year in the wake of the COVID pandemic. So there are 5 figures. The first figure is the pre-COVID, pre-lockdown pollution level. The entire India is in red, which is more than 80 microgram per cubic meter. But you can see that different phases of lockdown, although there is a large improvement in the air quality, but we could not sustain the air quality below our national standard. Why? Because during lockdown, most of the outdoor sources were switched off, like transport was off, emissions for power plants were at minimum level. There was industries not emitting. However, the household emissions continued, and also there are open burning. And because of these regional sources, we have seen that air pollution really did not go below the national standard. And it again, raises the importance of targeting the regional sources in India. And not just in India, even there are studies done in the global context also. But particularly, this example I've taken from Just Ladwell's group, where they have identified the dominant source across the world for outdoor air pollution. And again, you can see that India and East Asia are shown in blue. And this represents the residential emissions or household emissions. Large part of Africa, you can see that the dominant source is natural dust. Same for Australia. If you go to Europe, mostly it's from agricultural and other sources. And then in US, actually, we have transport, industry, and all these sources. So this is the most dominant source. It does not mean that there are no other sources. But it gives you an idea that the source characteristics differ from country to country, and that means the air quality management plan also has to differ. Now, the biggest challenge at this moment for developing country like India is to convince the regulatory agencies and the policy makers that air pollution is a silent killer. It's very, very difficult to persuade. There are reasons also for that. So one reason is that, when you calculate the mortality or morbidity burden for air pollution, these numbers are difficult to validate because we do not have a very good cause-specific mortality database. And even if the database exists, ultimately, autopsy is not done to ultimately pinpoint that this particular death has occurred due to air pollution. The second important reason why this is the case is that health impact symptoms develop over the years. So there is a kind of, so it's not an immediate impact. So all the different diseases that can occur due to exposure to high level of air pollution take years. And that is why, usually we get kind of used to it, and we really do not think that air pollution actually is causing so much harm. And we must remember that air pollution is actually a health risk factor, not the cause of the disease. However, most recently, this case in UK where for the first time in autopsy air pollution is identified as direct cause of death could probably, open the Pandora box. And I'm sure in other countries, they will also realize the importance of having detailed cause-specific health mortality and morbidity data sets and further address these issues. However, what we have found also at the same time is that if we generate indigenous evidence of the health impact, that really helps in convincing the government that, look, there are data which are showing big impact on health due to the exposure in air pollution. For example, a lot of studies are conducted now in India, including our group, where we have found that exposure to high level of PM2.5 is associated with several child health outcomes. For example, child stunting and wasting, which I mentioned earlier, We have done recently a study with US colleagues to look into the impact on child mortality. And even in the Global Burden of Disease India initiative, air pollution is identified as the third largest factor for child mortality in India, after malnutrition and water poor sanitation facilities. There are studies which have shown that exposure to high level of air pollution during pregnancy leads to low birth weight of the baby. And again, it has severe health implications. And most recently, we have also found significant association of air pollution with child anemia. Now, India is one country which has very high prevalence of child and adult anemia. And again, both for child and adult anemia, we have found impact of air pollution. For the adult populations, again, there are evidence showing the impact on cardiovascular disease, cognitive performance, and various other health outcomes. And also, not just for, in general, total air pollution, both outdoor and indoor. There are some studies now coming out with targeted source-specific health impacts. For example, the studies which I've listed in the last row, what we have found is that people living in close proximity to crop residue burning. Now, crop residue burning, I'm sure many of you are familiar. It's a big problem in India, particularly in the North India. And what we have found is that people who live in very close proximity to where actually the crop residue is burnt, they are more prone to respiratory disease, and also these people are more prone to being hypertensive. That means they have elevated blood pressure level, which is again a very major health risk factor for having various other cardiovascular diseases. And what I found is that since these studies actually utilize India-specific health data, it's easier actually to articulate the message not to just to the government but also to the common people. So if we want to look forward to the sustainable future, what are the steps we must take? So in India, now we have launched National Clean Air Program because we have realized that air pollution is a national scale problem. We cannot just deal air pollution by reducing emissions within the cities. We have to adopt a regional airshed approach. And at the same time, we have to ensure strict compliance to emission norms. And ultimately, we have to gradually shift to clean energy. So the source apportionment studies carried out in India identifies at least 7 to 8 major sources of air pollution. As I mentioned, household is the number one. But in addition to household, there is a big contribution from thermal power plants, which usually use coal, a contribution from industry, transport sector, open biomass burning, brick kilns, and then there are many other unorganized sectors. So there are actually plans for each of these sectors. However, the key lies in successful implementation of the plan, because when we talk about policy, again, science can only help policy formulation, but ultimate success depends on how successfully you are actually implementing the plan. Because again, when it comes to the implementation of the plan, in the recent past, we have experienced that a good policy does not always bring the desired results because of the failure in the implementation. Again, India is a big country, so there are limitations in terms of resources. There are limitations in terms of regulation. And again, the scientific community in India is working with the government to ensure, and also the messaging, which is actually now being tried under the National Clean Air Program, is that the citizens also have to be part of the entire air pollution in dialogue. And that's what actually we're talking about, the stakeholder engagement. The other important point is that when you have so many different sources to tackle, we must prioritize mitigation measures. So for example, if anyone asks like which source we need to prioritize, is it household, is it transport? We also need to keep in mind that prioritization should depend on multiple factors. One is that the cost of the implementation. Second important factor is we need to keep in mind the ease of implementation. And different sources require different time frames. For example, if you are talking about reducing air pollution from let's say industrial sources, and you cannot just overnight change the industrial infrastructure. It will take years. And that is why actually we need to come up with cost-effective measures. And again, recently the EASA group has come up with different scenarios, which I'm showing in this figure here, in this particular slide. And they have done some cost effectiveness analysis, like which will be cost effective, which will be quick, which will take time, and then they have proposed that under different scenarios what will happen. And more such analysis is required both at the national and international scale. Now, as I mentioned that Southeast Asia having the highest level of exposure, so obviously currently, the entire attention has turned into the Southeast Asian countries, including, China, India, and other countries in this particular part of the world. The problems are quite unique in this part of the world, but at the same time, I personally believe that there is an opportunity to learn from the experience of US or European Union, particularly in addressing the particulate matter air pollution problem. However, the problem is not completely resolved in the developed countries. And as I mentioned that even if the PM 2.5 level is quite low in those countries, what it has been observed, particularly in Europe and many Canadian and US cities, that surface ozone is still on the higher side. And then again, PM 2.5, we must keep in mind that is not the only criteria air pollutant. So there are many other air pollutants like NOx, SOx, ozone. So if we win the battle against PM 2.5, we must ensure that ozone does not go up. So it's a challenging task. If you are already at the lower end of the exposure spectrum, as I mentioned, the challenge is to convince the government that we need to really go further down the line and ultimately come around such a low number where you ensure that there is minimal health impact, because when you are already at lower exposure range, further lowering it down is also very difficult, because we have almost taken all the major steps that is possible to bring the air pollution level to that only. When you are at the higher end of the spectrum, there are other challenges, particularly this part of the world, because of the high population density, many interventions measures are difficult to implement. And that is the challenge actually India is currently facing now. However, the scientific community is working to resolve this issue. I'm pretty hopeful that we'll be successful in reducing the air pollution in another 10 years or so. So my concluding thought is that we must show urgency and seriousness in mitigating air pollution. And as I demonstrated that air pollution and climate change, they are interlinked, although I did not discuss about air pollution and climate change linkage in this particular talk, but I must mention that in the current conditions, we should handle the air pollution and climate change in an integrated manner, and mainly prioritizing the measures which can provide both climate and health co-benefits. And in a country like India, I personally feel that we must invest in exploring the new frontiers like the issue of toxicity, and we should have long-term cohort studies to further strengthen the India-specific health impact assessment. And for that also we need flexibility in the current curriculum and overall governing system, which can further promote interdisciplinary research. So I just want to acknowledge various funding agencies, and I will stop here, and I'll be very happy to answer any questions. And thank you again for listening patiently. Thank you.
Thank you, Sagnik, for the interesting talk. I work on aerosols. However, there was so much in this talk that I didn't know about related to the risks to health, and as you said, it has to be like a collaboration between not just aerosol scientists or climate scientists, but also people from medicine background and people like social scientists. So we haven't got any questions from the attendees yet, but I do have a few questions to kickstart it. What is there any effort at all towards moving to this interdisciplinary approach at all? Because it's a massive scale of collaboration that we are looking at. Has it started at all, especially in a country like India?
Yes, actually it has started. So there are several efforts to have that kind of interdisciplinary programs under, and in fact, both in terms of the institutional infrastructure, there are funding mechanisms now made available for only interdisciplinary research. That means, those fundings are only available if the proposal is interdisciplinary. And this is to ensure that you actually, target. In fact, there was we actually are currently doing an Indo-UK in a project under Indo-UK bilateral program, where we have actually on board environmental scientists like me, medical scientists from AIMS, and then epidemiologists from Sinamchand University, and also it's a mixed interdisciplinary field where actually all different aspects are being investigated. So yes, so the importance of interdisciplinary research has been realized in India. There is a push. However, I personally feel that still there is a lack of adequate capacity in actually carrying out such interdisciplinary research, particularly because of the rigidity in some of the curricula. For example, I will give you one example. Like, so I am from IIT, which is an engineering and science institute. In an IIT, let's say if someone wants to do impact, studies on health impact, we do not have adequate courses in medical science and all. So now, because of those limitations, provisions are being made where course credit, credit transfer, and if the student can attend some courses from medical institutions and all. Yeah, so some efforts are there in that direction, but mainly for the premier institutions, unless we also motivate the universities and a large scale of institutions across India. I mean, that has to be there.
Right. Yeah, and I imagine it will be a bigger problem as well because of the lack of health data, which you were explaining. It is really hard to just track down a death that has been caused by air pollution. And then there is a lack of health database as well in India, which I probably imagine is like much easier to get in a place like the UK because you have the NHS. Right, I'll move on to a question by Max. So Max asks, since the climate effects depend on the chemistry of the particulates, like black carbon versus sulfate, could you comment on what the distribution of these might be in India? Example is the PM 2.5, mostly organic aerosols, black carbon, or sulfate? And how might these affect co-benefits with the climate change mitigation? Right, I think it's probably something related to your research as well. I'll let you answer that.
Yeah, I think that's a great question. In fact, there are multiple questions in that. So I will answer one by one. So in terms of chemical compositions, what we have found is that almost 50% of PM 2.5 is secondary, and it's not just the sulfate, but sulfate and nitrate. Because and if you look into the air pollution, if you look into the precursor gases concentration like SOx and NOx in India, it's pretty low. And for quite a long time, people thought that we are not emitting SOx and NOx. But later people realized that, it's not like that we are not emitting SOx and NOx. In fact, we are emitting SOx and NOx quite a lot. But our atmosphere is conducive for converting SOx and NOx to secondary particulate matter because we have so much ammonia present in our atmosphere. And it means that also in terms of air quality management, we must also give a lot of effort to reduce SOx and NOx emissions. and not just focus on the primary PM 2.5 emission sources. That's number one point. Second point is that composition varies seasonally depending on the sources. For example, in winter, when we have very high prevalence of open burning, so there is large increase in the organic aerosols. Black carbon is very high, particularly in the Indo-Gangetic Plain, which is the northern Indian region. So I will give you some estimates. So what we have found is that 5 to 10% of PM is black carbon. In terms of absolute concentration, we have measured black carbon in Delhi during winter time to the order of 20 to 30, 40 microgram per cubic meter. Just imagine this number. PM 2.5 guideline for 24 hours from WHO is 25 microgram per cubic meter. We are talking about black carbon, just similar amount. And in fact, in that time, actually, we have PM 2.5 exceeding 400, 450 microgram per cubic meter. And why this is so important? Because the third point is extremely important. I didn't get much time to dwell upon this. Recently, there is a study conducted by the Lelwell's group who has shown that when you talk about mitigating air pollution, it's extremely important to focus on whether you are reducing black carbon or you're reducing sulfate. Because we all know that black carbon is a short-lived climate pollutant. So obviously, the mitigation measures targeting reduction of black carbon must be prioritized, because if you reduce black carbon, particularly in country like India, you are not only reducing PM 2.5 load, but also since black carbon is adding to the warming of the climate, you are also tackling that. Now, having said that, what also has been found is that high anthropogenic aerosol loading in India is one of the major cause of suppression of monsoon rainfall. And again, in their simulation study, because their study is based on simulations, because obviously these are scenarios, what they found is that if you reduce anthropogenic aerosol emissions in order to reduce air pollution, as a bonus, what would happen is that your monsoon rainfall will go up. So there are multiple feedback mechanisms. In fact, we have also found that in a recent study that it matters whether you are trying to target sulfate mitigation or you're trying to target black carbon mitigation. So more research is required because there are only a handful of studies there. And the other important point, which it's not, I mean, Matt did not ask this, but I'm saying why composition is so important, because I personally believe, and now in fact the air pollution epidemiology is moving in that direction, that so far all the health impact studies are based on PM mass. We are not sure how the health risk varies as a function of composition. So that means for the same level of exposure, if a person is exposed to black carbon versus sulfate, will the health risk differ? We simply do not have answer to such questions. However, this is what we trying to answer currently, that with the indigenous health data, what kind of composition is important, and again, that will give a sense of prioritization.
Right, thank you very much. It's clearly a really complicated feedback mechanism at work there. We have another question, time for another question from Dr. Shiva Shakti. Thank you for the wonderful talk. I just want to know that what could be the reason behind the mortality rate in India being so low when compared to China, although in China, PM 2.5 level is lower than in India. Yeah, does that make sense to you?
Yeah, no, so I just want to, so it's not actually the mortality rate what I showed the total mortality. So when you calculate total mortality burden from air pollution, we must also keep in mind that mortality burden attributable to air pollution not just depends on the exposure level, but it also depends on the population and the age of the population. And also the third important factor is the background disease rate or baseline mortality rate. So because China and India have very high population, in fact, China has higher population than India. So although the pollution exposure is lower in China compared to India, what we have found is that the total mortality is higher in China. If you calculate the rate, in fact, I did not show the rate, but if you go to the GBD website, you can check the rate. In fact, in terms of rate, mortality rate, India has the highest mortality rate. The reason is that our baseline mortality is quite high. And baseline mortality implies that for any disease which can be linked to air pollution, because there could be multiple risk factors for a particular disease. And in India, the typical diseases which are attributable to air pollution, there are multiple other risk factors which actually impact the baseline mortality rate. So in terms of mortality rate, in fact, India has higher mortality rate compared to China.
Right, thank you very much. I think it's time to close the meeting because we are hitting the maximum time limit. So thank you very much for the talk. I really enjoyed it, and I hope our attendees enjoyed that as well. If you can take some time to thank Dr. Sagnik Dey, that would be amazing. Thanks again for giving the talk, Dr. Sagnik Dey, especially given the time in India at the moment. So
yeah, it's a pleasure. Thank you.
Thank you. This was our last talk for the 2020-21 academic year. We will come back again in October with a new series of talk, and the first one to start with will be a talk on 14th October, which will be about how radar is connected with insects. It will be a talk given by Freya Addison from University of Leeds, and I'm sure you'll enjoy that a lot. So until we meet again, stay safe, and we hope to see you all back again in the next year. Thank you very much.